Right, welcome to this presentation. I'm just going to be doing N3 exam. So this is a South African mathematics paper for technical colleges. Your people want to be electricians, eventually maybe even engineers, electricians, mechanics, fitters and turners. They will all have to do this exam if they want to go up to N3 level. And this is an exam that was written 23rd November and 2011. So Mathematics N3, Department of Education, South Africa. Okay, let's just get started. So what I'm going to do is that this is not meant to be like a professionally scripted video. This is not a TV program. I'm not selling this for millions. I'm going to put it up there for you to use as you want to and benefit from. So let's just start without ado. Question 1, simplify without using calculator. Okay, so what I'm going to do is I'm just going to copy this to my drawing program, and then I'll do it for you on the screen. Okay, so let's have a look at this question. Simplify without a calculator. So what they're looking for is can you do the question? Or, you know, obviously you can type this into your calculator, but they're going to want to look for the steps. Okay, seems like I've got a limited drawing area here. It's fine. For now I'll make do with it. So let's see. The fourth root of 16 multiplied by 81. Now if you multiply square root on the inside, let's just see this. This is basically the fourth root of 16, that's 2. The fourth root of 81 is 3. 2 times 3 is 6. This just tests your conceptual understanding. If this was plus, it would be a whole different ball game. You'd have to factor out a certain number. Well, let's look at this now. 1 over 3. I'm going to do this one over here. 1 over 3 plus 1 over 4. What I would do immediately is just take this notation and just divide it. Divide it by 4 over 5 plus 5 over 6. Okay, so it's all of this, isn't it? Divided by all of that. So what I would do is I would simplify inside here and inside here, and eventually you have something on something else, and then I'll just turn this to multiply and tip and turn it, right? So if we look at this, the least common denominator will be 12, so I'm going to multiply this by 4 over 4 and this one by 3 over 3, right? 4 times 3 is 12. So what I'll have is 4 over 12 plus 3 over 12, correct? Divided by, now I'll do the same here. I want to change the base to 30. 5 times 6 is 30, but that's also the least common denominator. So this one's 6 over 6, this one is 5 over 5. I'm going to multiply each term by that. So yeah, 4 times 6, 24 over 30 plus 25 over 30. Okay, now I'm ready. I'm going to run out of tablet area here because of my settings, but for now I'm ready to kind of combine these. So let's look at our next step. Our next step would be to combine this 4 plus 3 over 12. That's just going to give me 7 over 12, correct? Divided by 24 plus 25, that's 49 over 30. And now if you remember primary school fractions, you just say multiply it, that becomes 30 and that becomes 49. Now if you remember your cancelling, 7 goes into itself once, 49 7 times 12, 6 goes into 12, 6 times 2 is 12, so 6 goes into 12 twice, 6 goes into 35 times, and your final answer is 5 over 7. Can't really, whoa, mistake, 2 times 7, 14, that would be our final answer. Okay, I'm going to quickly pause the video so I can extend my writing area, or maybe we won't. Got an idea. This seems to work. So let's do the next question. we're still simplifying. Always read your questions properly. We're still simplifying. We're not trying to find the value for x. We're still just simplifying. So let's have a look at this. 2 times 3 to the x minus 3 to the x minus 2. 5 times 3 to the x. So what I would do here, this stays 2 times 3 to the x. 3 to the x minus 2 looks like this. 3 to the x times 3 minus 2. Minus 2. Notice the reason, just quickly to review, 2 times, let's say 5. Isn't that 2 times 2 times 2 times 3? So you add them, don't you? So that'll be 2 plus 3. Correct? That makes sense. So what if I gave you 2 to the k minus f? Well, that'll be 2 to the k times 2 to the negative f. So that would actually be 2 to the k over 2 to the f. I hope this makes sense to you. You can break this up just like you do this. So if this doesn't make sense to you, pause the video, write this down, think about it a little, suppose rewind, not rewind, go back in time in the video and make sense of that. Okay, so coming back to our problem, 3 times 3 to the power of x minus 2, that's just 3 to the x times 3 to the negative 2, 5 times 3 to the x. So next step here would be to say, what's nice is everything's multiplied except this negative. So there's a 3 to the x in each one of these terms. Here we have a term, and here we have a term. They're separated by that minus. So that's kind of like having 2k squared minus k. What you do is you take a k out, right? 2k minus 1. So we're going to do that same thing, except we're not going to take a k out. There's a 3 to the x in each term, right? That's what we're going to take out. We're going to take out a 3 to the x, and what we'll have left, 2 times 3 to the x, negative 2 to the power of negative 2. And this is 5 times 3 to the x. So now you should notice immediately that cancels with that. So you got 2 minus 2 to the negative 2 over 5. And now we could worry about the value of this. 2 to the negative 2, that just means it goes to the bottom right. So you got 1 over 2 to the 2 over 5. You know, you've got 2 minus a quarter, basically, which is 1 3/4. You got divided by 5, that's the same as times by 1 over 5, right? And I suppose you would just use your calculator here, but I don't have a calculator now on screen. So that's 7 over 4 times 1 over 5 and 7 over 20. There's your final answer. I think that's correct. So let's move on. Our next question, factorize fully into prime factors. So I'm gonna copy these two in one. Wow, it's quite big. We're gonna factorize these. This looks like it wants to be a difference of squares. Sorry, just having some coffee here. Okay, it wants to be a difference of squares, but obviously I can't take the square root of 8 or 50. But hey, if I divided 2 out, 2 times 25 is 50, isn't it? And 2 times negative 4 is negative 8. So now we've got a difference of squares. So that'll be the square root of 25x squared is just 5x. 5x, square root of 4 is just 2 and 2, and then plus and minus. There we go, that question's done. Let's introduce a new color to be interesting. Now this next one, you got to realize you can take a plus b out. Here's an a, here's a b, there's another a, and there's a b. So you see these recurring patterns of a's and b's. So let's take what we can do here is basically leave this a plus b. Oh wow, white. Didn't intend for that. Anyway, looks quite cool. Times x squared. Okay, so now if I take out a negative 2, let's see what happens. Negative 2, well, negative 2 times a would negative 2ax. Negative 2 times b will be negative 2bx, so that's a plus b. So there we go. And if I just say plus a plus b, notice the amount of a plus b's we have. So think of a plus b is like, let's say, k, right? Then this would look like this. You'd have kx squared minus 2k plus k, right? Well, first of all, I mean, you could simplify this into kx squared minus k, but even more than that, the next step would be to take a k out, right? X squared minus 1, and then you could, that's a difference of squares. So we're going to do that exact same thing. We're going to, from step 1, we're going to take a plus b out. We're going to take our k, quote unquote, out. So I hope that makes sense to you. Let's think about it in that way. So let's take a plus b out of every single term here. So a plus b, and then we'll be left with x squared minus 2 plus 1, which is obviously x squared minus 1, which is going to be, I suppose I should have equal signs here, huh? A plus b, that's a difference of squares, x minus 1, x plus 1. Okay, I hope that makes sense to you. I hope you can forgive my bad handwriting. Okay, next one. Here's an interesting question. Wonder if I shouldn't zoom out a bit. The question occupied half my screen there. Prove that x minus 3 is a factor of the following equation. What is a factor? What is a factor? Well, if you have a Cartesian plane and you got some kind of, let's say, cubic equation here, passes through the origin, maybe turns here, goes down again, and passes a third time, okay? Some kind of cubic equation. Here x is, let's say, well, clearly x is 0, y is 0 here. Here is like, let's say x is 6. Obviously y is still 0 at that point, and here x is, let's say, 8. Y is 0. So your factors are x minus 6 and x minus 8. So you're basically your x-intercept. Often they'll ask for a remainder. So if for, let's say this is x of, let's say 4, and let's say the y value is, let's say 8, then here, if you divide by x minus 4, then your remainder is 8. But that's not this question. I hope you understand what a factor is. So they're asking us, if you put an x value, of course, if you put x of 6 into this equation, whatever it is, you should get a y of 0, correct? And then you know, hey, this is a factor. This is an x-intercept. Give me a second. There's an easier way to do this. Let's make that black and just rub this out quickly. Okay, so prove that this is a factor. All you do is, obviously, if x minus 3 equals 0, then x is positive 3, right? So let's put a function of 3 in. That'll be 6 times 3 cubed minus 13, 3 squared, minus 19 times 3 plus 12. And that must give you 0. Of course, we've got to prove a little bit better that it really is 0. I mean, I could put equal to 0 here, and the examiner will just maybe have to believe that I did punch this into my calculator. But I suppose 3 to the 3 is 23. 3 to the 2 is 9. 19, that's 57. 19 times 3 is 57. And this you can put into your calculator. If you get an answer of 0, then yes, for your x point of -3, your y point 0. Therefore, x minus 3 is a factor. I suppose, to be technical, you can say of f of x. Okay, next question. Here we've got a simple simplification question. Let me just copy this like this, maybe. Let's see. Here we go. Okay. Well, our first step is going to be, remember, there's no equal sign, well, except the one I just drew. I'm just going to say this equals this equals this equals this. There's no equal sign. You're not trying to find a value for x. You're just trying to simplify. So your first step is really just factorize. So here you can take out an x, right? X times x will be x squared. X times -2 will be -2x. Okay, same here. You can take out an x. You're going to have x times x is x squared. X times 1 will give you x. That's easy enough. Just trying to see, give myself just a little bit more space with this graphics tablet. Okay, here you're going to take an x out. And what? X times x squared is going to give you x cubed. X times -1 is going to give you x, right? This is a quadratic equation. You need to factorize this. So let's see. 2x and x will give you 2x squared. 1 and 1 will have to give you 1. Okay, so they're going to have to multiply up to a negative number, so the signs are going to have to be different. And we wanted to get to +1, so 2x times +1 is positive x. So minus 1 times x. So it's +2x minus x. That's going to give you positive x, which is what we're aiming for. Okay, so we're on our way to having this completely factorized. I can so long cancel that with that, right? X divided by x is 0, and I can cancel nothing more. Surprisingly, cancel nothing more. Yeah. I'm a bit surprised that I can't cancel this 2x here, but let's see, I took an x times x is x squared, x times -2 is -2x. So that's correct. I can't cancel more. Okay, so let's see, x minus 2 over x plus 1 times, or in algebraic notation, I like to use a dot. X times, okay, this is a difference of squares, right? I can square root the first part. X times x is x squared. 1 times 1 is 1. Plus, minus. That's a difference of squares. 2x minus 1. X plus 1. Okay. Wow, this is an interesting question. Really does not allow for a substantial amount of cancelling. It seems like your final answer is rather odd. Usually almost everything cancels. In fact, this is multiplied by an excess here. I've set my graphics tablet to only go so far. I can't go farther than this for the writing pen. Now you should be alarmed. If you do this in your test, you should wonder, this doesn't look right. So let's quickly have a look again. Let's see, x squared minus 2x. So we took out an x, got x minus 2 left. That's correct. Here we took out an x, we have x plus 1 left. That's 100% correct. We took out an x, we got x squared minus 1, which we factorized into x plus 1, x minus 1. 2x times 1 is 2x minus x, maybe plus 1 x. This seems like this is really our final answer. Nothing more that we can do. Okay, well, there you have it. Let's move on. But it was important to check because it's very uncommon for them to be so unsimplified. So, next step, we're almost done with question 1. Here we have division, but now what's very important to realize is there's no brackets here, right? So the divide only applies to that. Very, very important. It looks like it could apply to everything. It doesn't. It only applies to that. Wonder if there's a printing mistake here. But anyway, 3x over 2 plus x over 3, draw properly, times 5 over 2x Now, what's interesting here, I'll show you now. I haven't actually done this before in this particular test. Notice this is one term. That's one term, isn't it? It's got a multiply in the middle. Well, a divide, but now a multiply. So we can cross cancel within this block, within this term, because it's that times that. Maybe for clarity's sake, let's rewrite it. 3x over 2 plus, okay, so let's see, x times 5 is 5x, right? 3 times 2, that's 6x, minus 4x over 3. Now I should put an equal sign here to indicate that that equals this. I'm just simplifying. What's interesting here is these x's cancel, and now I'm left with 3x over 2 plus 5 over 6 minus 4x over 3. My next step would be to multiply each term by something such that would make the bases the same. So I want the bases to be 6, right? Because I can multiply this by 3 over 3. That I'll leave it as it is. This I'll multiply by 2 over 2. 3 times 3 is 9x over 6 plus 5 over 6. 4 times 2 is 8. 3 times 2 is 6. Does that make sense? I hope it does. And then the base will be 6, and I'll combine the top 9x plus 5 minus 8x. Okay, so obviously that's just x plus 5 over 6. I believe that to be the correct answer. Please leave a note for me in the comments below if I made a simple computational mistake. I'm not infallible. So that's question 1 done. 23 marks. It's interesting. Question 1 often for N3. I've seen many exams that up to a quarter of your marks comes from question 1. And really, I really want to encourage you, don't lose marks on what many people kind of shrug off as the easiest part of the test. This is the substantial portion of the test. If you can get all this right, if you can practice, get it all right, then you're halfway towards passing already. Okay, I'm going to pause here. I'll see you for question 2 in a second.